Right. So Jay, we are going to have certain discussions based on machine learning, statistics, and Python today.
Okay.
And I would like to start with Python, the
Okay.
first question, and that would be mainly from object-oriented programming, Python. Hmm. In object-oriented programming, we talk about different methods. There are basically three different types of method in object-oriented programming. What are those three methods?
So object-oriented programming like have four pillars like polymorphism, abstraction, and yeah. For now, I'm remembering two methods: polymorphism and abstraction.
Methods are different. These are the events. Methods are
Yeah.
different. Instance method, static method, class method.
Yeah. Classes, and it has its own functions which are called as methods.
Hmm.
Yeah.
Okay, okay. Now, um, are you aware of encapsulation?
Encapsulation, yes, but I have very little idea. So encapsulation, in the sense, it means that uh, if a parent, there is a parent data and it beholds all other data into its own feature.
Okay, okay. Basically, encapsulation is a technique that we follow to make a particular attribute private. Okay, that is the reason, that is the purpose why we use encapsulation.
Okay.
When you read more about encapsulation, you will learn about something called getter function or getter method, I should say, setter method. They are there. Okay, they are there. So maybe you can explore that part slightly. And so that is fine. Let's say if I talk about um, statistics, if we talk about statistics, and in statistics, we learn about concepts such as variance, standard deviation, and all such things, right? Now, if I talk about a Gaussian curve, okay, we understand what we mean by a Gaussian curve, right? A bell-shaped curve, right? So if we have a bell-shaped curve, which has a height, I should say, of, let's say, 20 units, the width is of 5 units. I hope you can imagine the graph. Height is of
Yeah.
20 and width is of just 5 units. So it's going to be something like this, right? Something like this. The base would be very narrow, right? If we have this kind of a graph when we represent the visualization. And on the other hand, we have a graph which has a height of, let's say, 22, and the base is quite broad this time. The base is, let's say, 20 units, and the height is 22. So it's more of a dome shape, right? So if you get these kind of visualizations in your graph, then what would you infer? Which one is having more variance? The one with a higher base or the one with a concentrated base? Variance would be high in which case?
Uh, so today I'm not able to recall.
Variance is what?
Yeah, variance is the difference between the actual values and the predicted values. So
So can we say variance represents spread?
uh, variance, yeah,
Can we say that? I'm asking.
yes.
I might be wrong. I'm asking you. Can we say? Is
So
it right?
variance, we can say that how much the values are being deflected from its mean centered positions.
How much they are spread out? How much they are
Yeah,
dispersed?
uh,
Can say.
yeah, they are deflected or diversified from the mean centered position. Yeah.
Now tell me what will be your answer?
Uh, Yeah, okay. So you are saying the height is low and the width is large, right? So this, it must indicate that the variance is being quite diverse because it's quite spread from its mean centered position. Yeah,
So the second graph that we would have with a broader base will have higher variance.
higher variance. Yeah.
Correct. Fine. Now, this is a question that I have been asking your friends also today, but unfortunately, None of them were able to answer. And that is the reason why I'll be asking the same question to you. Hopefully you will be able to give me a right answer, right? So the question is with respect to, again, statistics, hypothesis testing primarily. When we talk about hypothesis testing, and when we talk about multiple, listen to the question carefully. When we talk about multiple samples of different sample size, one sample can be of 20 data points, another sample can be of 50 data points, another one you can
Okay.
have of 50 data points, right?
Okay.
From the same population, you are having different samples. Okay. So when you have multiple samples in your data and you are
Okay.
supposed to validate your hypothesis, then what validation technique can you use?
Okay. Validation techniques. So are we talking about the different tests we can apply on it?
Yeah.
Uh, so I think like we can use the chi-squared test. So
What else? Because you have multiple samples. Remember, that is the catchword, multiple samples. You don't have one single sample. So if you don't have one single sample, Z test and T test are obviously neglected. है ना? Multiple
yeah,
samples. Think about it.
yeah. No, I'm not able to recall.
When you have more than one sample, any sample size, more than one sample, you will prefer t-test? No. You will prefer z-test? No. Chi-square? No. Just one option we have, that is called f-test or ANOVA.
Okay.
Okay, that is the peculiarity of that particular test. More than one sample, you can use f-test for that matter, right? So that is something which we have. All right. Now talking about, um, let's say, mm, when it comes to your visualizations, right? And specifically visualization using any business intelligence tool, right? It can be Power BI, it can be Tableau. So when it comes to visualization, you come across something called bar graph, you come across something called histogram. So what is the difference between the two? Because both of them apparently looks the same. What is the difference?
Okay. So yeah, so I can say about the bar graph. So bar graph basically, if for a current, if a given data set, if
Mm,
there are some features and those features have a certain values based numerical values, so we can present them in a bar graph. Like if the revenue of a certain company, different companies, they can be represented with the help of bar graph. So anyway, the x-axis can be the organization name, and the y can represent the revenue sales accordingly. Histogram, I'm a bit confused. I think histogram may be a comparison bar graph. Uh, so if yeah, I'm not able to recall, but I can say if we need to compare two year sales of a particular companies of taking an company, so we can represent it with the help of histogram.
all right.
Yes, but I'm not sure. Yeah.
All right. So when it comes to, when it comes to your bar graph, we can simply say that whenever it is something to do with a categorical variable and a numeric variable, when you are comparing a relation between these two, you can simply use a bar graph. Straightforward, one single line answer. Hmm. What you told me was right, but that was more of an application approach, right? So that is the idea. Yeah. Is it
Your
clear?
screen got frozen.
Am I
Yeah.
audible now?
Yeah.
Now can you
Yeah.
hear me?
Yeah. Yeah.
Hmm. So I was saying that whenever you are supposed to compare a categorical variable with that of a numeric variable, you can use a bar graph. The example that you gave me was completely right. But yes, when you are supposed to explain it to your recruiters in verbal sense, This is what you
Yeah.
can say.
Okay.
All right, fine, fair enough. Now, do you know something about inheritance in Python?
Uh, yeah. Inheritance. So suppose there is a child class and a parent class. So all the properties and the features which is present in the parent class,
Okay.
it may be subsequently get transferred to the child class also itself.
Using the concept of inheritance.
Yeah.
All right. In inheritance, we have different types, right? For example, there is something called multi-level inheritance. There is something called multiple inheritance, right? So what is the difference between the two?
Sorry. Yeah, I had actually gone through it, but yeah.
Use your common sense. I'll give you 2 minutes. Think about it. In the
Okay.
recruitment
Okay.
also. Hmm.
Yeah.
Think about it.
So okay, multiple level inheritance. I think a child can have those features from multiple parent class. It may belong to a multiple parent class, and in multi-level inheritance, I think if if uh, if there is a parent class and there is another class within sub another class, so those features are getting transferred through one child to its another subsequent child, like hierarchy. So a level is created, a hierarchy is created, kind of.
All right. More or less correct. More or less correct. So when it comes to multiple, the name suggests multiple. That means you will have more than one parent class. You can have a father class, you can have a mother class, and from both of them, you will inherit as a child, you will inherit the properties from both the parents or from both the father and mother at once. At one single instance, you would be acquiring the properties of both father and mother. Excuse me. So that is what you do in multiple inheritance, right? When it comes to multi-level, again, the name itself is self-explanatory. Multi-level means level after level you will have the classes. Let's say you have class A. Class A acts as a parent class for class B, which is a child class for parent class A. So class B will inherit the properties from class A. From class B, a third class, which is child class for class B, will inherit the properties. So eventually you will find that class C, which is the third most class in the order, will have properties from both A and B,
Yeah.
even though B is only the parent of class C.
Yeah.
But because B had inherited from A, that
Yeah.
is why C will have
Exactly.
B also, A also.
Yeah.
Correct? So that is what we have. All right. So what projects have you worked on till now?
uh, Projects regarding the academic projects, machine learning or
Machine
uh,
learning, basically. Machine learning or data analytics projects in
yeah. So the airline prediction detection, and then the predicting the liver stage of a particular patient based on different features.
All right. All right.
Yeah.
So that
Yeah.
was a binary classification or a multi-class classification problem?
That Yeah, since it was like different stages were there up to stage 4, it was it was not a binary classification, it was classification.
Multi-class classification.
Yeah.
Okay. So for multi-class classification, what algorithms do we have at our disposal?
Yeah. Yeah. So like we have decision tree for classification, we have decision tree and forest classification.
All right. All right. What else?
Okay.
What else? Decision
Yeah,
tree,
SVM.
SVM. Okay.
SVM is also used. Yeah.
All right. In random forest, we have a concept of bagging and boosting. What do we mean by
Yeah.
these?
Yeah. So what happens is uh, bagging, what we can say is we can use different models, uh, and we can apply them to different data sets of different data sets of that whole data set. and then based on the outcomes of those different models, we can find which has major votes, which has most probability, and then we can take the outcome. And boosting is what happens when the accuracy is low of a certain model. Then we need to increase those accuracy. Then what we do, we use various techniques, and we increase the accuracy of the model. So this is called boosting. So we use various techniques for like adding the penalty parameter, making changes in weights and bias, and some regularization technique. So we boost the model by making some changes in a traditional model.
Okay. Now, because you talked about regularization, what is L1 and L2 regularization?
Yeah. So basically, what regularization is, we add penalty parameter to cost function or loss function, and then what happens is we remove the over reliance of a particular feature which has less weight, and we give more weight to it. So what happens is, due to the updated weights, there is certain changes in the output of the model. So L1 regularization, what is there? We take the we add the values of the coefficient of the model. We map the coefficient of the model. We add the values to the loss function. And in L2 regularization, what we do, we add the value of the sum of the squared values of the coefficients model.
Okay. Okay. There are certain terminologies associated with them, like some specific names associated to them. So, what is L1 regularization otherwise called? L2 regularization otherwise called?
Uh, I don't know the other terms, but is it related to data augmentation?
No, no.
Those
Ridge
terms?
and lasso. Ridge
Uh,
and
Sorry?
ridge and lasso.
Okay, rich and raso regression. Yeah.
L1
Uh,
is ridge, L2 is
yeah.
lasso,
Yeah.
right?
Yeah.
So that is what we have. All right. One last question we'll have, and then we can wind up maybe. So, with respect to again machine learning, when we calculate the accuracy, along with the accuracy score, at times we also compute something called precision. Sometimes we compute recall. Hmm? So, can you give me the formulas for precision and recall?
Yeah. So precision is true positive upon true positive plus false negative, and recall is true positive upon true positive plus sorry precision is true positive upon true positive plus true negative, and recall is true positive upon true positive plus false negative.
Okay. Okay. So I think that's it from my side. Make sure that you have shared your updated resume with me on my like email ID, so that I'll go through it and I'll give you some constructive feedback if possible. Hmm?
Okay.
All right. Thank you so much, Jay.
Thank you. Yeah. Thank you.